The subject manufacturing. This is extremely important as far as the mechanical engineering is concerned. If you see the mechanical and production engineering, in both the cases the subject is common, because in both the streams the creation of the goods is a part of the program. In production and industrial engineering, the production is involved. Likewise, in mechanical, it is the production, design and thermal engineering. So the production is involved in both the cases, wherein the creation of the goods is the core. Creation of the goods is realized. Now these goods can be realized of any suitable material. It can be plastic, it can be wood, it can be metal. Whatever you see all around you, you will find that they are made of one or other material. Whether it is laptop or watch or chair or computer or motorcycle or cycle, anything, whatever you see, that would have been created by some procedure, some processes of some material. In this subject, we will try to see what are the broad approaches which are used for creation of the goods, of the metals or of the plastics. Okay, so the goods creation is the key here, and for creating the goods we need a variety of the materials as well as variety of the processes, because they are of the different sizes, different shapes, different complexities. Okay, if you see a car or motorcycle, you will see there is a sheet metal, there is a rubber in tires, there is a wheel, there is a plastic. So, and the number of types of the metals, like steel is also there, aluminium, cast iron, variety of the materials for making a product which is really usable for the human being, usable by the human being. So since the products are different, their roles are different, that is why they are made of the different materials, and that is why also we need the different processes as well. So here in this broad subject of manufacturing, we will first see what it is and why it is important to talk about this subject. But before getting into those things, let me talk a little bit about this content related aspect. This is the distribution of the mark, which shows the practical PRS of 25% weightage. We'll try to share the actual demonstration of the different processes which are carried out on the different machines, about which you'll be studying in this subject, and then based on your understanding of the subject, practical assessment will be carried out. Okay, so that's one. Then midterm, then end term examination weightage will be of the 50%. Okay, as far as the objective of the subject is concerned, main idea is behind to communicate, to introduce the different processes related with the manufacturing. In this particular subject, it is about the sheet metal forming, the removal of the material removal, and finishing operations. These are the three processes about which we'll be talking. But in this subject, but there the manufacturing, under the umbrella of manufacturing, there is a lot more. So we, in this subject, in this lecture particularly, I'll talk about all that. Okay, what is the scope of the manufacturing as a whole. Okay, so as far as the content of the subject is concerned, there are 4 chapters. The first is about the introduction of the manufacturing as well as manufacturing process itself, classification of the manufacturing process, applications, limitations, and what is the basis of selecting the processes. So this will take about the 2 lectures. Then the sheet metal forming. Now you will be knowing the all computers, laptops, boxes, trunks, the car bodies, motorcycle parts, number of parts are made of the sheet metal. So how to give the shape, how the required shape is realized, what are the different tools and the equipments need to be used for shaping the sheet metal. Sheet metal, like say half mm, 1 mm, 1.5 mm mild steel, GI sheet or titanium or aluminum, whatever sheet is there, a particular shape is given so that it is really usable for a given purpose. You must be seeing nowadays aluminum body laptops, also aluminum cars and motorcycles were there for long. Then whatever we are making, that is not very accurate in terms of the size and shape, so we need to give very accurate size and shape. That is realized through the material removal processes. So what are the different material removal or machining processes? And what are the different tools which are used in this? What are the related parameters which are involved in machining or removal of the material? And what are the common processes of the machining? About that we'll be talking in this chapter number 3. Okay, so the chapter number 2 basically involves the tools and equipments used for sheet metal forming and the different sheet metal operations. And in the chapter number 3, basically it involves the material removal processes and the tools and the equipments and the various operations which are used. Say, for just for an example, for manufacturing gears are like core of the mechanical engineering. They are used extensively primarily for power transmission. So manufacturing of gears is realized through, say, one simple milling operation, right? So for milling we need indexing. For manufacturing gear, like say this is the circumference of gear, this has to be divided into the equal parts. So the dividing the periphery of the gear circumference in equal divisions, this is realized through your indexing. So what are the different methods of indexing so that you get the required number of the teeth on the surface of gear? You may have 15 teeth, you may have 200 teeth, depending upon the purpose for which the gear is to be made. Okay, so these are the 3 chapters. So last chapter is related with the finishing. So as I said, whether you use the one manufacturing process or other, you don't get the exact size and shape that you are looking for. So for that purpose you need to do machining or material removal processes. But further, if we want much more or much higher surface finish, much closer tolerances, then abrasive finishing operations are carried out. They are not material removal processes. Here very thin layer of the material is removed through the grinding. Okay, so whether it is the surface grinding or the cylindrical or the curved shaped components for which need to be smoothed. So basically this is the finishing process, abrasive finishing process, which is basically here the grinding. So what are the different aspects related to the grinding? The different grinding machines, different types of the grinding, like surface grinding, cylindrical grinding or centerless grinding. And when the grinding wheel is used, we find that the grinding wheel goes out of the shape. So this has to be balanced, because when the grinding wheel is rotating at a high speed of say 2000-3000 rpm of very heavy mass, when it goes imbalanced, when it becomes imbalanced, then there is a huge tendency or the possibility of failure of the fracture of the grinding wheel. So whenever the grinding wheel fractures, all broken parts will be coming out like a bullet and they will damage man and machine. So a lot of things can happen, undesirable things can happen. So, and then lastly here it talks about the different what are the ways by which we can select the grinding wheel. Okay, what are the factors that we need to consider the selection of the grinding wheel? These are the different recommended books for this subject. So Kalpakjian, MP Grover, these are really very common books. The P.N. Rao is the Indian version. He has been the IT Delhi professor. He wrote very good book long back. This is the latest edition related with this book. So you can refer any of these books. These are good books. So as far as the content is concerned for this presentation, basically I will be talking about the need, then scope of the manufacturing process, and then classification or approach of the manufacturing, and what are the various materials involved when we talk of the different manufacturing processes. So for this purpose, now I will be using the whiteboard. Okay. So I'll be showing the PPT as well, but little later. Let us talk so that it goes as per my. See, the manufacturing is primarily used for making the goods, making the products which can be used by the human being. They are so we'll be using the raw material in form of metals, plastics, woods. So whenever we do the manufacturing, we'll be doing the sizing, we'll be changing the size as per our need, we'll be shaping. So these are the two broad things: size is changed or the shape is changed, so that we get the product as per our need. And third important aspect is imparting the properties. The material may not have the desired set of the properties, say in terms of strength, in terms of toughness, in terms of ductility. So those properties are also imparted through the suitable treatment approaches. That also falls under the manufacturing. This manufacturing can be done for making the products of very simple shape to the very complex shape. Four broad manufacturing processes are used for manufacturing. One is casting, second is forming, third is machining, and fourth is joining. What these are, I will talk in detail. This can be done for making the very simple to the very complex geometry. Like you see, this is a simple motorcycle. Here you have rubber, here you have the disc, steel brake disc here, and this is like the exhaust system. This is the sheet metal. So this is again sheet metal. Variety of the metals and plastics. If you see the cut section, probably you will find a lot more parts. Okay, so here different types of the gears, maybe the piston and cylinder assembly, the valves. Okay, so all these, so somewhere one type of metal, one type of product, one type of the part, one type of component. Since each is different in terms of size and shape, so definitely you need the different approach for manufacturing. Okay, so different approach means it can be made. Say if you take here itself, and as an example, if you see, if you take, so this is your cylinder head. Cylinder head is firstly made with the casting only, but whatever cylinder is made, cylinder head is made, that is not exactly as per our size and shape, so it has to be machined also. Okay, if you talk of the another component, like here we don't have the forming based part, but if you say yeah, but there is one. So these the shafts, these shafts are made of these shafts are made by the deformation based processes. Like the forming based processes are used for making the shaft. Springs are made by the forming processes. So lot of materials, lot of processes, lot of you can say the processes, materials, and to satisfy the requirement of the different shapes, sizes, and the properties. Okay, so the one system may require the different processes, casting, forming, to make the different components, and all these whatever you are making has to be assembled. So assembly is realized through the joining. So for making any usable product, you need the larger number of many processes. You need many processes so that each one can be given desired size and shape with the desired set of properties, and subsequently so that it can be given it can be all those parts can be brought together to make the product usable, and for that you need the joining. Now, about the joining, I will talk a little later, because here the joining may be simply assembling through the nuts and bolts and rivets, or it can be welding, brazing, or soldering kind of thing. Okay, so for making any usable product, you need the different materials, you need the different processes, so that the different components with the desired set of the properties can be made. Okay, so if you see the another one, this is the another example only. Here you have the piston cylinder assemblies, here you have the sheets which are given different shapes, and all these, and there is a chassis, a steel chassis to take the load of the entire structure, maybe aluminum alloy wheels. So these are made through the different processes. We'll say alloy wheels are made by, say, casting. The piston and cylinders are made by casting. Forming, you need to make a sheet metal forming is needed to give the desired shape to all these steel sheet that you see, and all these are connected through the welding, spot welding, particularly spot welding or the joining kind of thing is used. So the different process, and all these cast products are certainly machined to get that final size and shape. Okay, so all if you take any product, they will be made of the different materials, and they need the different processes to get the desired size and shape. Okay, so now I'll go to define the manufacturing. If you have to understand the manufacturing, as I said, it is used for creation of the goods, but if you have to understand technically, the manufacturing is defined as a process of converting the raw material into the useful product. Okay, useful product. But if you see, this is the technically it is about the conversion of the raw material into the final finished product, so that it can be used for the purposes as per the application. And manufacturing is also an economic activity wherein the raw material, which is of simple shape of the rod or the plate, it is given the desired shape so that it is used. So raw material is shaped to the useful products through, so basically it involves the value addition. So through the manufacturing, you give the desired size and shape to the raw material to make it usable through, so it is a value addition. Initially its value, say simply steel, if you talk of, is steel made used in bicycle is just of 50 rupees kg. Okay, but when that is steel is used for making the bicycle or car or like say motorcycle, the value becomes high. Okay, so that's why it's a value addition process, or technically it is the process of converting the raw material into the useful products. Why do we need this? We need manufacturing to create the goods. Why do we need creation of goods? No, to support the human being. No, if you talk of your parents or the grandparents, in like say in late 70s or 80s, hardly there were motorcycles or cars, very few, right? Even till 1991, there was just one brand of the car, like say just you had the Maruti. So hardly there were options. So very limited motorcycles, very limited cars, very few cars were there. People were mostly relying on bicycles or the walking to cover the distances. Things changed, the time has changed, the technologies have changed, and that has led to the lot of mining, making the materials, then making using those materials, manufacturing the goods, and making all those goods available to the masses. You know, and that is why you will see in a simple village you may see hundreds of the motorcycles, tens of the cars. So in general, by making or by creating the goods, we are simply trying to improve the standard of living, which was not there earlier. People were living in very poor condition. So the need of the manufacturing is to create the goods so that the standard of living of the human being can be improved. Okay, and how it is done? You need to use the resources. For creation of goods, you need to use the resources in form of raw material, which may be aluminum, which may be iron, which may be rubber, or anything else. You need to use the raw material and then give the desired shape so that usable products and the goods are made. I'm just giving the example. So and all this is done in such a way that with the use of the minimum raw material, you are able to get the more and more output. Okay, so that it is, the entire process is productive, it is cheap, okay, it is low cost, so that it is within the reach of the masses. That's what is being done. Like, just for an example, I am quoting the Tata. It is manufacturing a wide range of the products, and that is also making it available at the low cost. So there are a lot of companies which do this kind of the service, and it is expected that engineers also come out with those innovative materials, with those innovative processes which are able to help the creation of the goods and creation of the products for the human being, for masses, for citizens, for publics. So how it is possible? Making the use of less and less raw material, more and more can be produced, so that it will be less costly and it will be have the greater reach to the masses. Okay, if the same thing is very costly, you will see that the number of buyers and purchasers will be reduced. So basically, we need to use the resources. We need to use the resources. In these resources are basically in form of material, in form of machine, and the man, machines, and the material. Now these may be in different forms. Like, you are using the minerals, you are using the crude oil, you are using the water, you are using the sunlight, you are using the fishing. So there is a whole lot of the resources are available, and these are processed through a set of plants, machineries, and the human being. So a combination of these three helps to get the products and the service products at the cheaper rate, and making the things in larger volume. So basically, the creation of goods is written like this: use the natural resources multiplied by use of natural resources by the man. So when the man will be working using a natural resource, like carpenter is working on wood to make the furniture, this process is slow. So if the man is supported by the machines, then the output is enhanced significantly. So here this is the power of the machine. So machine helps to increase the rate of production. More goods can be created with the minimum wastage in shorter time. Okay, so this is a simple way to express how the output can be enhanced with the use of the machine. Natural resource, man, when the two will be working, the output can be enhanced when it is coupled with the suitable kind of machinery. Okay, now we can use a range of the natural resource, which may be in form of air. Like, say, people are extracting the hydrogen, water for hydropower, then heat, then solar plants, sunlight, then animals. So these are the natural resources, and the tools may be in form of your wheat, agriculture product. All those are natural resources. Mining things are natural resources. So that in the tools, machine tool, what I said, machine tool means all machineries, plants, all machineries which are there in the plants to make the goods. And so based on the way by which these two things, the natural resources and the machinery is used, we can categorize the industry in three ways. Like, so the industry which is relying on, which is completely based on the natural resource, like agriculture, this is called primary industry. Mining means, mining also has the two parts. One is like say oil exploration, or like the crude oil production, fishing, agriculture I have already written. So mining, agriculture, etc. So all those industries which are relying on which are involved in or their product is of like say the agriculture, like wheat or pulses or related things, oil exploration, fishing, crude oil production, etc. All these are the primary industry. So the secondary industry is one which is using the output of the primary resource. So here you will have the manufacturing. So whether making the bread from the wheat, okay, making the cars using the metals of the mining industry, produced through the, like say, iron ore is processed to make the steel. So the steel, using the steel or aluminum, if the usable goods are produced, then this falls in the manufacturing industry. So so in the secondary industry, use the products of the primary industry for secondary processing or further processing for making the useful goods. Then there is a tertiary industry. Tertiary industry is basically the service industry. Here it is just like banking, hospitality, medical, transportation, education, etc. All that falls under the tertiary industry. Okay, so here that is about just to have idea of where manufacturing falls. Manufacturing is basically the secondary industry which uses the raw material being produced, which uses the products of some primary industry in form of like the steel or the aluminum or the whatever raw material is to be used. Okay, so if we have to understand what the manufacturing process is, manufacturing process is basically the science and technology of manufacturing products. How? So how this product has to be made? Product has to be made very efficiently, effectively, economically, and without damaging or harming to the environment. So this is what is needed. The processes which are efficient, effective, economical, and environment friendly. So efforts are made to realize the products with these following attributes. So this is done using in three ways. One, using the existing resources, like whatever plant, machinery, or the material or manpower is available. Use the existing resources. This is one, use the existing resources. Second, selection, like since there is a wide variety of options available for making the same goods and products, so the selection of suitable processes, materials, and the parameters, where, what, and how much is to be used, so that it is efficient, the process is efficient, effective, and economical and environment friendly. At the same time, it also involves, like the manufacturing process which is basically the science and technology of the manufacturing the goods. It also involves the improving the existing processes and materials. Okay, and lastly, if you don't have the enough capability to process a particular material, or you don't have the material which can serve the given purpose, then development of new material itself or the new processes. You must have heard the breakthrough technologies are developed. So breakthrough technologies are also developed in manufacturing domain. Okay, so these are this is what you can say science and technology behind the manufacturing, for manufacturing the goods efficiently, economically, environment friendly and effectively, using the existing resources through the suitable selection of the process parameters and materials, while at the same time, if required, improvement of the existing processes so that it is economical and effective. And for a given purpose, if you don't have material and processes, then develop the new materials and new processes as well. Okay, why there is a need to develop? I will talk a little bit more on this need of R&D in manufacturing, need to develop the newer things. What is the need? The need is compelled by the so many factors. The primary one, see, there is a huge competition. You may get one bike at 40,000, you may get one bike at 50,000, and there is always throat-cut competition to come out with good performance at low cost. You know, so how it is possible? You make the good products available at the low cost. How it is possible? It's possible only if your productivity is extremely good. You make more using less, so the cost is less. Okay, so that is one. Productivity is good. You don't waste much on manpower, on material, on resources, on time or energy, whatever you have as an input resource, not much is wasted. The second is also to see that quality is good. So it is important to continue to keep on developing the newer and newer manufacturing processes so that the productivity is enhanced, the quality of product is enhanced, and it is at the same time economical. Okay, so that you can give enough competition to your competitors. If you do not do this, you will be out of the market. It is very simple. Like earlier, Nokia was dominating in the market. Now it is nowhere. It is just like that. If you don't continue to innovate and continue to do the development and R&D in manufacturing, in products, in technologies, then certainly after some time the people will be out of. The company will be out of the market. So this is important. That it is continue to do the R&D in manufacturing as well. Okay. Second important thing is miniaturization, making the things small and small and small in size. Like something is to be inserted in thy body for endoscopy, so it must be smooth, it must be small in size so that it doesn't harm the human being who is being tested using the endoscopy, you know. So the miniaturization in robotics, miniaturization in n number of sectors is important. So the medical and the electronics are the two dominating fields, and it is more difficult to make the things which are extremely small or which are extremely big, both the sides. So making the things of extreme sizes is difficult. We need the different technologies to manufacture those things. So miniaturization is one that compels us to do lot of R&D in manufacturing. Then precision. You keep on making the same thing again and again so that the repeatability is good. The dimensional tolerance is really good. So you can replace easily one product with another. Tolerance. Closer the tolerance. Earlier, if you had the variability of 0.1 mm, you will always be striving for 0.05 mm, so that the variability in the dimensions is minimized and you can easily replace without compromising the performance. Okay. And the third factor is, since to deal with the challenges of the newer and newer harsh conditions, to deal with the challenges of the more severe and the harsh conditions of the products which we'll be experiencing. I'll give example. Earlier, thermal power plants were working, say, in temperature range of 450 to 550. Now, now thereafter the development of the supercritical thermal power plants, the temperature range increased from 550 to 650. With the further increase in temperature for ultra supercritical thermal power plant, temperature went further high up to 750. You know, the metals get weakened when they are exposed to the high temperature, so they will not be able to sustain, and they will yield, they will deform, they will fracture. Okay, so to work under the severe harsh conditions, it is important that the material is able to withstand. That is why lot of the newer materials have been developed. When the new material is brought in, you need the different technology, because conventional things may not be effective. So to manufacture the newer materials, especially for those which are coming in aerospace, spacecraft, nuclear plants, so whatever newer materials are being used to deal with the challenges, you need the different approaches, different technologies. Okay, so now coming to the manufacture, that's why there is a need to improve the productivity, quality and economics, to deal with the miniaturization, challenges of miniaturization, precision and tolerance, and to manufacture the goods and products of the newer materials which are being developed for working under more harsh and severe conditions. Now, as far as the manufacturing is concerned, there are four main processes. So what we'll say, overall manufacturing process can be grouped in two categories. One is called conventional, okay, and second you can call as a newer or unconventional. Okay, conventional ones are of, like, say, primary forming processes. What these are? Primary shaping or forming. So means in primary forming processes, you try to realize the larger shape. You say earlier the raw material is in form of this block, and you want to make it of, say, a particular shape, this. So initially it is converted into this shape through the primary shaping. It may not be of exact size and shape, but you reach close to that what you want. So the primary shaping or forming, this is one type of the process, and for this raw material of any shape can be brought into the desired shape, close to the desired shape. So the primary shaping or forming is realized through these three processes. One is called casting, where the material is melted and then it is solidified in the mold of the desired shape. Forming, you try to deform. Bulk deformation helps to get the shape desired. This is plastic deformation based approach. And then powder metallurgy, PM, powder metallurgy approach. Here powders are compacted in the shape desired, so that desired shape is realized. Desired shape of product of desired shape is realized. So it involves like compaction, sintering, and then machining finally. So powder is compacted, then it is sintered, and then it is machined. So in using these three processes, here you bring the metal to the liquid state, it remains in the solid state, but it is deformed plastically, and here material comes in form of the powders. It is compacted in powder metallurgy route, compacted, then sintered, and then machined. So this is one category of the process, primary shaping. Okay, then we have the machining, or it is called material removal processes. Material removal processes. Say if this is the raw material and you want a product of this shape, right? So all this extra material has to be removed, simple. Okay, so whatever unwanted extra material is there, that is removed to get the desired size and shape. This approach is called machining. So here this is called material removal or the machining approach. Okay, so lot of machining processes are used to get the desired size and shape. Say if you want, just for an example, if you want to make a hole, then there is a drilling process. Okay, so the different so as far as the broad approaches are concerned, the raw material is subjected to the controlled removal of the material to get the desired size and shape in machining or material removal category. In third, that is called joining processes. Joining processes is used for those cases where, like say, simple shapes are brought together to get the desired shape. Like say, if your gear is of large size, so what will be making the gear in 4 different parts, like this. This is one, this is another, this is another, okay, like this, and this is another. So the gear part 1, 2, 3 and 4 all will be joined together. If it is of extremely large size, this is also possible. Okay, so when the product is very complex, then the simple parts are brought together using the joining approach. In the joining, we use the 3 processes. One is called welding, another is called soldering, and the third is called brazing. Okay, probably about this you will be learning in subsequently in some other subject. So this is like the simpler shapes are being brought together to get the desired size and shape. So this is called addition process. The earlier one was the removal process or the negative process, where the material was getting removed. In the first process, where primary forming was taking place, just we were shifting the material from one zone to another. There was no loss. Like say in forming, material is in this shape, and after the deformation, it is brought to this shape. So the material has shifted. Like say the length has increased, thickness has reduced. So the shifting of the material from one zone to another. The same is true for casting and the powder metallurgy. Lastly, the fourth one, regenerative processes. Regenerative processes, this is the latest and newer category of the process, wherein what you see, this is called layer by layer approach. Layer by layer approach. So depending upon nowadays, like say additive manufacturing, rapid prototyping, they are the part of this regenerative process, where in regenerative processes the material may be used in different forms. Like say the liquid material in liquid form is used in stereolithography. Material in powder form is used in case of the selective laser sintering to get the desired size and shape. Material in form of sheet is used to make the laminated objects. So it is in all these cases layer by layer the material is deposited, then the desired size and shape is realized. And when the material is used in the form of wire, it is wire material is fused and it is deposited layer by layer to get the desired size and shape. So basically these regenerative processes use these are based on the layer by layer approach. Primarily these use CAD and computer aided design and computer aided manufacturing coupled with the rapid prototyping to apply where how much material is to be applied, so you get the desired size and shape of the product. Okay, so we are talking about the conventional ones only. Lastly, there is one more thing that falls under the category of the manufacturing, that is about the improving the properties of the material, improving the properties of material. You know, when you make any product either by casting or by forming or by welding or by machining, you may see that it is not of the desired, say, strength, just 500 MPa, elongation is just 20%, hardness is just 10 HRC. So this may not be sufficient. If you feel that the properties are not good enough, so let's apply some kind of the treatment. So means the material is subjected to the property enhancement processes. So there are two approaches wherein the property enhancement is possible through the bulk material property enhancement and or just the surface layer property enhancement. So what is the difference in these two? In bulk material, the whole section material properties will be modified, and in the case of the surface layer property enhancement, only the thin layer of the surface of the material, properties of the surface layers will get modified. Okay, so primarily in bulk material property enhancement, the heat treatment is used. So there are variety of heat treatments. Okay, just to name, like there is annealing, normalizing, quenching or hardening, tempering, cross tempering, etc. Then there is a T4, T6 heat treatment. So depending upon the kind of metal systems, different heat treatments are given for bulk property enhancement. Similarly, for surface property enhancement, there is a like burnishing, there is a shot peening, there is a friction stir processing. These are solid or these are mechanical based processes, not heat treatment based. Then there is a case hardening, and then laser hardening, electron beam hardening, plasma hardening. These are like the thermal based processes. So laser hardening, plasma hardening, case hardening, all these are heat treatment based. So in these cases only the surface layer properties will be modified. Okay, so if you see, there is a very wide range of the processes as the conventional manufacturing process is concerned. But conventional manufacturing processes are good for the materials of the moderate properties. Okay, moderate properties. What is this? Like say limited strength, proper materials having the limited strength, limited hardness, limited melting point. If these properties are highly skewed, say melting point is 4000, no, you cannot apply these manufacturing process like casting, welding, forming. Similarly, the strength is say 2500 MPa. You cannot apply. Hardness is say 100 RC, HRC. So you cannot apply any of the processes about which I have talked, whether it is casting, welding or machining or your forming. None of these processes will be suitable. Lot of materials of late has been developed for very harsh application conditions, wherein they can sustain very high temperature, they can retain the high hardness and strength in very tough conditions. So those cannot be processed using these conventional processes, and that is why you need unconventional or newer processes, newer category of process. So there is electron discharge machining, electro discharge machining, electrochemical machining, ultrasonic machining, then laser beam machining. Okay, so these are some newer or unconventional machining processes, okay, to process or to manufacture the products which are of very high yield strength, very high melting point, very high hardness. So which cannot be, so the materials which cannot be processed using these conventional things can be processed to use these unconventional processes. So this is the difference. Okay, Now, lastly, I will talk about the another compelling factor for using the newer processes is the unique geometrical requirement. What are those? Like normally we make a hole of 1 mm, 1.5 mm, but if you want to make a hole of 10 micrometer, then how you will do? And that too hole of say 1 mm hole of say 10 mm depth. You cannot do this easily. Maybe 1 mm hole or of say 2 mm depth is workable using the drilling processes, but very fine hole size of very large depth, very high aspect ratio, not doable certainly. Or similarly very thin sheets need to be given very complex shape, that is also not workable using those conventional processes. So to satisfy the geometrical requirement of manufacturing the certain products, also you need the newer manufacturing or the machining processes, wherein the conventional processes of the casting, welding, forming or machining do not fit in properly. Okay, so this is about the conventional and unconventional processes. So that's all. Probably I have talked about all these things. In the next lecture I will be talking about a little detail of these conventional manufacturing processes, their applications, advantages, disadvantages, and how do we choose the manufacturing processes. How do we choose the manufacturing process for manufacturing the goods? Okay, so that is what probably we'll be talking in the next lecture that will be held on Monday. Okay, thereafter the next chapter on the sheet metal forming will be taken up by our other professors.